Welcome to School of Computing. As part of Programming Foundations sessions, we have discussed functional units of a computer in the last session. In today's video, we will try to understand number systems and its importance in digital computer. Since computer is an electronic device, it can only sense presence of voltage and its absence. Presence of voltage is interpreted as 1 and absence is treated as 0. So any command or instruction given to the computer will be in the form of ones and zeros, and hence the language understood by the computer is called as binary language because it contains only two digits 1 and 0. This binary language is also known as machine language because machine understands it. And since computer understands only binary language, it is very important for us to understand the number systems because we deal with decimal numbers and computer understands only binary numbers. So we need to understand how to convert a decimal number into binary and what are the other number systems that are used inside a computer. Now, not only the language understood by computer is binary, means not only the instructions, even the data represented will be in the form of binary. So whether you deal with text data, an image or a video, whatever may be the type of data, it will be stored in the form of binary only. So CPU can only understand binary form of data. So the units of data measurement will also be in the form of binary. So before we move on to number systems, we need to understand the units of data measurement as well. Units of data measurement. So the smallest unit of data in a digital computer is 1 bit. Bit stands for binary digit. Binary digit. It can be either 1 or 0. 4 bits together is called as 1 nibble and 8 bits is 1 byte. 1 kilobyte is 2 power 10. Since computer understands binary language, the base of the number system is base 2. So 1 kilo is nothing but 2 power 10 and 1 megabyte is 2 power 20 bytes. 1 giga is 2 power 30 and 1 tera is 2 power 40 bytes. 2 power 50 is 1 petabyte. 2 power 60 is called as 1 hexabyte. 2 power 70 is 1 zettabyte. And 1 yottabyte is 2 power 80. Friends, it's very important to note that capital B is represents a byte. So wherever we write capital B, it is byte, and small b represents bits. Generally, you might have noticed internet bandwidth will be measured in the form of bits per second, like 100 Mbps, 200 Mbps. So whenever we talk about internet bandwidth, we use bits. And whenever we try to measure the data or a file size, we talk in terms of bytes. I have a 5 GB file, 100 bytes of data. So when we talk about data or size of a file, we talk in terms of bytes. And when we talk about internet bandwidth, we talk in terms of bits. So if at all you find anything written in small b, it is bit, and anything written in capital B is byte. And It is very important for everyone to remember this. How much is 1 kilobyte? How much is 1 gigabyte? Because we regularly deal with memory, right? Because as I said in our previous session also, two basic elements of any program are code and data, and data gets created in the memory. So we need to understand memory as well. So when we are going to deal with memory, we talk in terms of these kilobytes, megabytes. So it is important for us to understand the units of data measurement, and this is how we measure the data, and these are the standard units. So 1 kb is 2 power 10, 1 giga is 2 power 30, and 1 yottabyte is 2 power 80. So these are the units of data measurement. Moving on, we will try to understand number systems in a detailed way. So the number systems, first one, obviously the binary number system, because computer understands binary number system. So in binary number system, the base is 2, because there are only two possible numbers, 1 and 0. And the number system which we follow or which we use is decimal number system. Decimal number system, and we know the base is 10. The possible digits of decimal number system are 0 to 9. Now it is very important for us to understand the conversion between decimal to binary and binary to decimal, because the number system which we use is decimal and the number system which computer uses is binary. So let us try to understand this conversion. So for example, let us say I have a number called as 15, and I wanted to find binary form of 15. The base of binary number system is 2, and if I wanted to find binary form of 15, then I need to perform this division. This is a LCM method which you might have done in your schooling. I'm just applying the same method. So 15 will be divided by 2. So 2 sevens, it is 14, remainder is 1. 2 threes is 6, remainder is 1. Then 2 ones is 1, remainder is 1. Remember, we need to collect the answer in the reverse direction from bottom to top. It means the answer is 1, 1, 1, 1. So friends, this is how you convert a decimal number into binary form. So I can call this one as base 2. Another example, because in this case we got same number in either direction. So for example, if you take 8, if I want to convert 8 into binary form, same process will be repeated. 2 fours is 8, remainder is 0. Then 2 twos is 4, 0. 2 ones are 2, 0. So as I said, we need to collect the answer in the reverse direction, and hence the binary form of 8 is 1, 0, 0, 0, base 2. So friends, this is how we convert a decimal number into binary. We have another method, a standard method, for representing a decimal number into binary form, and that standard method is called as 8421 code. It's called as 8421 code. What is this 8421 code? 8421 code is nothing but the face value of each digit or each position based on binary number system. It means in decimal number system we have something called as ones, tens, hundreds, which represents the face value of a particular position. And similarly, in binary, we do have the same thing, but the base will change. So here I got 1 because the face value of first digit is 1. It is because of 2 power 0. 2 power 0 is 1. And the face value of second position is 2 power 1. And 2 power 1 is 2. 2 power 2 is 4. 2 power 3 is 8. And this continues. For example, this is 16. Then it is 2 power 4. And the face value of the next position is 2 power 5, which is 32. 2 power 6, it is 64, and so on and so on. It continues like that. So friends, let us apply this 8421 code to convert a given decimal number into binary. For example, I wanted this decimal number called as 30 base 10 to be converted into binary. So what should I do? You need to add those face values which are resulting into 30. For example, 16 plus 8 is 24, 24 plus 8 is 28, 28 plus 2 is 30. So in those positions, if I write 1, means 16 is 1, 8, 16 plus 8 is 24, 24 plus 4 is 28, 28 plus 2 is 30, and this 1 is there, I'll put a 0. So straight away this becomes the binary form of 30. So friends, I hope this 8421 code is clear to you. So what exactly we are doing here? If you cross check, how do I cross check this? 0 into 2 power 0. 2 power 0 is the position. 2 power 0 is the position of that particular value. 1 into 2 power 1, face value of second position. Then 1 into 2 power 2 plus 1 into 2 power 3 plus 1 into 2 power 4. So 2 power 4 is 16, 1 into 16 is 16, 2 power 3 is 8, 8 into 1 is 8, then 4, then 2, then 0, which is nothing but 30. So friends, this is a very simple and standard method of representing binary numbers or decimal numbers in binary form. So similarly, when a binary number is given, by applying this multiplication method, you can convert the binary number back to a decimal number. So this is how you convert a binary number back to decimal number. So since we deal with binary numbers, since everything is in the form of binary, we need to convert decimal to binary number system. Now there are few important points to be noted here with respect to this 8421 code. What is that important point? For example, This is 8421 code. 8421, and you know it continues like up to infinite, 8 4 16 32, like that, so on. Now for example, if I only consider 4 bits, so let us take number of bits are only 4. With 4 bits, right, what is the smallest value I can represent? 4 positions we have, right? So this is 0, this is 0, this is 0, this is 0. Means decimal equivalent, if you say, I can represent 0. 0 is the smallest number possible. And what is the biggest number possible? The biggest number possible is 1, 1, 1, 1. All ones. And when I say all ones, then the maximum value possible is 15. So friends, please note, with n bits, with n bits, how many different numbers can be represented, starting from 0 to, if n value is 4, I am considering n as 4. So with n bits means in this case it is 4. So with n bits, how many different values are possible? 0 to 15 means total 16 values are possible, which is nothing but 2 power n. So with n bits maximum, how many different numbers can be represented is 2 power n, and with n bits, with n bits, the biggest number or the largest number that can be represented, the largest number that can be represented is 2 power n minus 1. In this case, it is 2 power 4 minus 1, which is 16 minus 1, 15. So these are two important points to be noted. With n bits, the biggest possible number is 2 power n minus 1, and the maximum number of numbers that can be represented is 2 power n. So this is a very important point. Now since we have seen decimal to binary conversion and binary to decimal, there are a couple of other number systems which are useful. Let us review the same. Now for example, I have 8421 code. Let us say, let us take any number. Let me take 31. What will be the binary code of 31? Binary code of 31 is 16, 8, 4, 2, 1. So 16 will be 1, 8 will be 1, 4 will be 1. 16 plus 8, 24, 24 plus 4, 28, 28 plus 2, 30, and this one will also be 1. So 5 ones is the binary code of 31. Now like that, if we are dealing with very big numbers, then the binary code of the number will also be very long. We do have couple of other number systems like octal number system. Octal number system means we have 8 numbers in it. 8 numbers starting from 0 to 7. So it's called as base 8 number system. Octal number system and binary number system, there is a relationship. Octal number system means 8 numbers, and in binary we have only 2. So, what is the relationship? 2 power 3 is 8. It means that 3 binary digits, group of 3 binary digits, equals to 1 octal digit. 1 octal digit. So, what do you mean by this? It means, for example, I have a binary code, some binary code. Let us say this is the binary code 1000011111000. So, friends, this is a very big binary code, and now let us say I would like to convert this into octal. So what need to be done? Starting from right, 3 digits grouped together represents one binary value. So 3 digits represents one binary value. So triple zero, three ones. We have to do this process from right to left. 001 and 100. Yeah, let me repeat this. I'll take one octal number, any binary number, and let's try to convert it into octal. So what is the process? Grouping 3 bits. Here I am left with only one digit, so I can assume two zeros and I'll make it a combination of 3 bits. So as apply 8421 code, triple one is nothing but 7, 011 is 3, 010 is 2, this is 0 and this is 1. So the equivalent octal representation is 10237 for the above binary number. Friends, similarly, we do have something called as hexadecimal number system. Hexadecimal. Hexadecimal means there are 16 digits in it. In decimal number system we have 10. In hexa we have 16, starting from 0 to 9. Then we have something called as A, comma B, comma C, D, E and F. This is F. And the relationship between binary and hexadecimal is 2 power 4 is 16. Binary number system base is 2. 2 power 4 is 16. It means 4 binary digits is equal to 1 hexadecimal digit. So what do you mean by this? 4 bits of binary can be grouped to form one hexadecimal digit. I'll try to convert the same binary number into hexa. 001, 000, 010, 011, then followed by 3 ones. So when we are trying to convert it into hexadecimal, we need to group 4 bits, then these 4, and finally I am left with 2 zeros, so I can assume another 2 zeros. Of course it will become 0 only, so I can ignore this component. Now when I say 4 ones, 4 ones means as per 8421 code it is 15, but in hexadecimal number system 15 means what? 0 to 9 we have 10 is A, 11 is B, C is 12, 13, 14, 15. So 15 means it is capital F. And 0100 is nothing but, as per 8421 code, it is 4, and 1000 is 8, and 4 zeros is of course 0. So the equivalent hexadecimal number system or number for the given binary code is 84F base 16. So friends, where do we use these hexadecimal numbers? Hexadecimal number system is used to represent addresses. Of course, memory address is always a binary code, no doubt in that. It's a very big binary code. But whenever we try to print that address, especially in our programming experience, in our programming practice, we come across situations where we need to deal with addresses also. In that case, instead of showing a very big binary code, that address will be represented or shown using hexadecimal number system. Means the address will be converted into an hexadecimal number, and then that hexadecimal number will be returned or printed. That is the reason whenever you print some addresses, you may find some alphabets in that address. It is because of hexadecimal number system. Of course, internally the address is always a big binary code. So friends, this might have given you a fair understanding of number systems, especially binary to decimal conversion, decimal to binary, and how to use octal and hexadecimal, or how to convert binary numbers into octal and hexadecimal numbers. So, as part of our programming foundations, we have discussed functional units of computer in our previous session. Now we have discussed number systems, and in the upcoming video session we will be discussing memory addressing, which is very important to start our programming journey. So I hope this particular video session gave you a good learning experience on number systems, and we will continue in the next session the memory addressing concept, which is a very important aspect of programming foundations, and which will help us in learning programming comfortably. Till then, thank you.